Assalamualaikum and hi everyone. Now we continue with second subtopic 9.2 Poisson distribution. Poisson distributions. If we are interested in the number of occurrences that take place in an interval time, then we use the Poisson distribution. Situations to be modeled by Poisson distribution are an experiment consists of counting the number of times. So biasanya Poisson distribution melibatkan masa. The variable x is the number of occurrences in the given interval is written as x p naught with lambda, where lambda is the parameter of the Poisson distribution and lambda greater than 0. When the Poisson distribution is appropriate, the probability of exactly x occurs is given by the formula px equals to x equals to e power of negative lambda times with lambda power of x and divide by x factorial. And this formula we just use for equal signs only. We look example 3 number 1. If x p naught with lambda equals to 6, find the probability by using the Poisson formula. First question, we want to find px equals to 3. Formula for Poisson we just use for equal signs only. And this one we have x equals to 3. So we just direct use formula. We substitute lambda with 6 and x equals to 3. This one refer to lambda and this one refer to x. So equals to e power of negative lambda 6 lambda 6 power of x 3 divided by x factorial. So 3 factorial. Then we calculate, we get answer 0.0892. Question B, we want to find p x greater than or equals to 2. For Poisson distribution, we doesn't have value for n. So kita tak tahu x greater than or equals to 2 tu kita nak kira daripada 2 sampai berapa. Sebab dia tak ada bagi nilai n. So untuk Poisson dia tak ada nilai n. So kita tak boleh kira lah 2 sampai berapa. So kita gunakan kaedah yang kedua. We take 1 minus px less than 2. And less than 2 we have px equals to 0 plus with px equals to 1. Then we substitute formula for 0 and 1. So we get 1 minus e power of negative lambda 6 power of 0 divided by 0 factorial. Then we plus with e power of negative 6 power of 1 divided by 1 factorial. We calculate, we get answer 1 minus 0.0174. Then final answer we get 0.9826. Next question C, we want to find px less than 2. Px less than 2 refer to px equals to 0. We plus with px equals to 1. We already find in B. So the answer is 0.0174. And next question D, we want to find between 3 until 5. 3 until 5 means we want to find value for 4 and 5 only. Since 3 doesn't have equal sign, so we start from 4 until 5. So we state px equals to 4. Then we plus with px equals to 5. Then we substitute formula. Remember, formula ini kita guna hanya untuk equal sign sahaja. So we substitute e power of negative lambda. Lambda is 6 power of x divided by x factorial. Then we plus e power of negative lambda. Lambda power of x divided by x factorial. Then we solve, we get answer 0.2945. Question number 2. An average of 3 cars arrive at a highway toll gates every minute. If this rate is approximately Poisson distribution, what is the probability that exactly 5 cars will arrive in 1 minute and 7 cars will arrive in 5 minutes. Okay, before we start solve, we determine the lambda first, the value for lambda. An average of 3 cars arrive at a highway toll gate every minute. So 3 cars refer to lambda. Apa-apa yang melibatkan masa itu adalah refer kepada parameter lambda. So we have X with Poisson distribution which lambda is 3. 3 cars arrive every minute. So this lambda for every minute. Okay, first question, 5 cars will arrive in 1 minute. So means we want to find Px equals to 5. So we substitute into formula. We have e power of negative lambda. Lambda is 3 times with 3 power of x. X is 5 and divide by 5 factorial. Then we solve. We get answer 0.1008. Next question, 7 cars will arrive in 5 minutes. We have lambda 3 for every minute, means 3 car for 1 minute. Now we want to find 7 cars in 5 minutes. So we need to find new lambda. 3 for 1 minute. So for 5 minutes, we have lambda equals to 15. 3 lambda for 1 minute. So 5 minutes. So we have lambda equals to 15. Question asks to find 7 cars. So we find Px equals to 7. Then we substitute into formula. E power of negative 15. 15 power of 7. And divide by 7 factorial. Then we solve. We get answer 0.0104. Question number 3. Emergency calls to an ambulance service are received at random times at an average of 2 per hour. Means dalam masa 1 jam, dia akan dapat 2 panggilan kecemasan. Calculate the probability that in a randomly chosen 1 hour period, A. No emergency calls are received and exactly 1 call is received in the first half hour and exactly 1 call is received in the second half. Okay, first we take out the information. We return X Poisson with lambda 2. This lambda refer to 1 hour. Question A. No emergency calls are received. Means we want to find Px equals to 0. So we just substitute into formula. E power of negative lambda. Lambda power of x divided by x factorial. Then we solve. We get answer 0.1353. Question B. Exactly 1 call is received in the first half hour and exactly 1 call is received in the second half. Soalan ni dia dah divide half hour and half hour. So kalau dalam masa setengah jam, panggilan kecemasan dia hanya 1. So kita ubah X with Poisson with lambda 1. Sebab kita nak cari exactly 1 call dalam masa setengah jam. So dalam masa setengah jam, kita punya lambda dah bertukar jadi 1. 1 jam 2, kalau setengah jam jadi 1. So we want to find Px equals to 1. And exactly 1 call means 2 kali Px equals to 1. Dia ada 2 exactly 1 call is received in the first half hour. This one Px equals to 1. And exactly 1 call is received in the second half. So plus Px equals to 1. Kita pisahkan. Ini setengah jam yang pertama. Ini setengah jam yang kedua. Then we substitute formula. We get e power of negative 1. Lambda 1 power of 1 divided by 1 factorial. Then we plus with the same value. Then we solve. We get answer 0.3679. We plus with 0.3679. So equals to 0.7353.